Okay, reheat Rankine cycle. So how can we take advantage of the increased efficiencies at higher boiler pressures without facing the problem of excessive moisture at the final stages of the turbine? So the answer is superheat the steam to very high temperature. Yeah, it is limited metallurgically. Okay, expand the steam in the turbine into 2 stages and reheat in between. So we need to reheat again the steam in the turbine. Okay, so let's see what will happen. So this is what happened. This is what does it mean. So this is the pump. This is still the same from 1 to 2, going into boiler. Okay, and then going to a turbine, but this time we have 2 types of turbine. We have high pressure turbine, we have low pressure turbine. So it goes into high pressure turbine first. Going up from turbine, it will be reheated again in a boiler. Okay, reheated again in a boiler. Okay, so previously when you go up from turbine, it goes straight to the condenser, right? But this time it will go out to, it will be reheated again in a boiler. Okay, but the pressure is still the same. Pressure of state number 4 and state number 3 is still the same. It is also called as P reheat. Okay, and then going to the lower pressure turbine. Okay, so when and it come out from lower pressure turbine and then goes to the condenser, and then it becomes and then the process is continuous. Okay, the difference between Rankine cycle and reheat Rankine cycle is it is reheat again. Therefore you have 2 types of turbine, high pressure turbine and low pressure turbine. The others is just the same. Okay, so from this diagram, it represented by this diagram. So this is the difference. So from 1 to 2, 2 to 3, the same thing, right? But this time you have 4, right? You have 4. Okay, going to reheat again at 5. Okay, going up. Okay, so the same pressure, and number 3 going to 4, and then reheat again. Reheating, and number 5 going straight to the number 6. This time we have 6, right? Okay, 6 before goes into condenser. So this one is for low pressure turbine. This one is for high pressure turbine. Okay, so what happened to the equation? Okay, so the Q in, you have 2 types of Q in, which Q in is Q primary, right? This is the beginning, the Q in, the first Q in. The second one is the reheated, Q primary plus Q reheat. Okay, therefore your Q in just now is actually previously it is just about H3 minus H2, but this time for Q reheat, what is the exit? The exit is H5 minus H4. So if you want to know what is your Q in must include both of these. Okay, the total of Q that being supplied. Okay, so for the same goes for the work. You have you are producing 2 types of work right now. Work high pressure and work turbine 2 from the high pressure plus the low pressure turbine. So you have the combination of these 2. So H3 minus H4 plus H5 minus H6. So the total of work turbine out is, you need to include both of these. Okay, therefore you need to find each of these, the value of each of these, H2, H3, H4, H5, H5, H6. Okay, so that is the energy analysis that you need to do to solve this kind of problem. Okay, so this is the additional info. The single reheat in a modern power plant improves the cycle efficiency by 4 to 5% by increasing the average temperature at which heat is transferred to the steam. Okay, so and the average temperature during the reheat process can be increased by increasing the number of expansion and reheat stages, and approach an isothermal process at the maximum temperature. So the use of more than 2 reheat stages is not practical. Okay, it doesn't mean that you adding 2, 3, 4, 5 reheat to make it more efficient and more efficient. So it's not practical. the theoretical improvement in efficiency from the second reheat is about half of that which results from a single reheat. So, yeah, we need to consider this, okay? So, the reheat temperature are very close or equal to the turbine inlet temperature. Yeah, and the optimum reheat pressure is about 1/4 of the maximum cycle pressure. Okay, even though we are improving this, so you can't put a lot of stages at here. Okay, so the average temperature at which heat is transferred during reheating increases as the number of reheat stages is increases. So it's not good when the heat transferred during reheating is increasing. Okay, so what is the purpose of reheat cycle? Yeah, what is the purpose of reheat cycle? Okay, get back to your objective.